Black holes. Just the name sparks curiosity. They're these regions in space where gravity is so strong, nothing, not even light, can escape. It's like a cosmic vacuum cleaner on steroids. But what if we wanted to get rid of one? Could we actually destroy a black hole? Imagine trying to blow up a giant vacuum cleaner with a firecracker. That's kind of what we're dealing with here. Black holes are incredibly dense and powerful, but like everything else in the universe, they have their quirks. In this cosmic adventure, we'll explore the mind-boggling world of black holes. We'll uncover their secrets and see if we can find a way to dismantle these gravitational behemoths. So buckle up, space cadets. It's going to be a wild ride. First things first, let's break down what a black hole actually is. Picture a giant cosmic cookie monster gobbling up everything in its path. That's kind of what a black hole does, but instead of cookies, it devours matter and energy. The mouth of this cosmic monster is called the event horizon. Once you cross that point of no return, there's no escaping the black hole's gravitational pull. It's like falling into a waterfall, only there's no bottom. Now you might think black holes are just empty spaces, but they're actually quite the opposite. They're incredibly dense, meaning they pack a lot of mass into a small space. Imagine squeezing the entire Earth into a marble. That's how dense a black hole is. But don't worry, black holes aren't roaming the cosmos, hunting down planets to devour. They mostly just hang out, slowly sucking in any material that gets too close. Think of them as cosmic recycling centers, breaking down matter and spitting out energy. Now, let's talk about destroying these cosmic cookie monsters. It's not as easy as it sounds. Remember that extreme gravity? It makes it pretty hard to just throw a bomb in there and call it a day. But there might be a way to slowly shrink a black hole, like putting it on a cosmic diet. It's called Hawking radiation, named after the brilliant physicist Stephen Hawking. Imagine the event horizon as a bustling city street. Particles are constantly popping in and out of existence like cars zipping around. Sometimes one of these particles falls into the black hole, while its partner escapes. This escaping particle carries away a tiny bit of the black hole's energy, causing it to shrink ever so slightly. It's like the black hole is slowly evaporating one particle at a time, but here's the catch. Hawking radiation is incredibly slow. We're talking billions and billions of years for a black hole to completely evaporate. So while it's technically possible, it's not exactly a quick fix. Now, some people have wondered if we could create our own mini black holes using particle accelerators like the Large Hadron Collider. Could these tiny black holes wreak havoc on Earth? It's a valid concern, but scientists assure us that these miniature black holes, if they even form, would evaporate almost instantly due to Hawking radiation. They'd be like microscopic firecrackers, fizzling out before they could do any damage. Think of it this way. You wouldn't be worried about a single grain of sand collapsing into a black hole and swallowing your house, right? These mini black holes would be even smaller and less stable than that. So while the idea of creating black holes in a lab sounds like something out of a science fiction movie, it's not a threat to our planet. In fact, studying these hypothetical mini black holes could teach us a lot about the universe. Let's say we did want to destroy a black hole the old-fashioned way, with brute force. Could we crack it open like an egg and see what's inside? Well, the universe might have something to say about that. There's a hypothesis called the cosmic censorship conjecture, which basically states that nature doesn't like naked singularities. A singularity is the infinitely dense point at the center of a black hole, where all the mass is concentrated. The conjecture suggests that singularities are always hidden behind event horizons, like a protective veil. It's like the universe is saying, what happens in a black hole stays in a black hole. So even if we could somehow overcome the immense gravity and reach the singularity, we might not be able to see it. The universe has a knack for keeping its secrets hidden. Now let's venture into the realm of pure speculation. Some theories suggest that black holes might be portals to other universes, like cosmic doorways connecting different realities. Imagine jumping into a black hole and ending up in a parallel universe where gravity works differently or time runs backward. It's a mind-bending concept, but not entirely impossible according to some physicists. If black holes are indeed gateways to other universes, then destroying one could have unforeseen consequences. It might sever the connection between realities or even collapse the entire multiverse. Of course, this is all highly theoretical, but it's fun to consider the possibilities. Who knows what other secrets these cosmic enigmas hold? One of the biggest mysteries surrounding black holes is what happens to the information that falls into them. According to quantum mechanics, information cannot be destroyed, only transformed, but black holes seem to break this rule. Once something crosses the event horizon, it's gone forever, along with all the information it carried. It's like throwing a book into a fire and watching it burn to ashes. This creates a paradox. How can information be both conserved and destroyed? Physicists are still grappling with this puzzle, trying to reconcile the laws of quantum mechanics with the nature of black holes. Some theories suggest that the information isn't truly lost, but rather encoded on the event horizon, like a cosmic hard drive. Others propose that black holes eventually release the information in a scrambled form, like a cosmic blender. The information paradox highlights just how much we still don't know about black holes. They challenge our understanding of the universe and push the boundaries of theoretical physics. Now let's fast forward to the distant future. What happens when the universe is populated by countless black holes, all slowly gobbling up the remaining matter? Some cosmologists believe that the universe might end in a big crunch, the opposite of the Big Bang. In this scenario, gravity eventually overpowers the expansion of the universe, causing everything to collapse back in on itself. Black holes would play a major role in this cosmic implosion, merging with each other and growing larger and larger until they consume everything in existence. It would be the ultimate cosmic feast, followed by a spectacular collapse. But don't worry, this hypothetical event is billions, if not trillions, of years in the future. We have plenty of time to study black holes and maybe even figure out a way to prevent the big crunch. So, we've explored some ways to potentially destroy black holes, from slow evaporation through Hawking radiation to hypothetical collisions with other universes. But what's the most likely fate of these cosmic behemoths? It's a cosmic tug-of-war between two opposing forces: Hawking radiation, which slowly shrinks black holes, and the relentless pull of gravity, which draws in more matter and makes them grow. Which force will ultimately win out? It's a question that continues to baffle astrophysicists. If Hawking radiation prevails, black holes will slowly evaporate over eons, releasing their energy back into the universe. But if gravity reigns supreme, black holes will continue to grow, merging with each other and eventually dominating the cosmos. The universe would become a dark and empty place ruled by these invisible gravitational giants. Only time will tell which fate awaits these enigmatic objects. But one thing is certain: black holes will continue to fascinate and challenge us, pushing the boundaries of our understanding of the universe. In our quest to understand the cosmos, black holes stand out as some of the most perplexing and awe-inspiring objects ever discovered. They challenge our intuition, defy our imagination, and push the limits of our scientific knowledge. While we've made remarkable progress in unraveling their secrets, black holes continue to pose more questions than answers. Can we truly destroy them? Are they gateways to other universes? What happens to the information that falls into their grasp? These questions will likely occupy astrophysicists for generations to come, but that's part of what makes studying black holes so captivating. They represent the ultimate frontier of human knowledge, a cosmic enigma waiting to be solved. For those eager to delve deeper into the mysteries of black holes, a wealth of resources awaits. From popular science books to online lectures and documentaries, there's no shortage of ways to expand your understanding of these cosmic wonders. Here are a few suggestions for further exploration. Books like Black Holes and Time Warps, Einstein's Outrageous Legacy by Kip Thorne, A Brief History of Time by Stephen Hawking, and The Black Hole War, My Battle with Stephen Hawking to Make the World Safe for Quantum Mechanics by Leonard Susskind. Websites such as NASA Science Black Holes, Space.com-Black Holes, and How Stuff Works, How Black Holes Work. Documentaries like Black Holes, The Edge of All We Know, 2020, Cosmos, A Space-Time Odyssey, 2014, and Into the Universe with Stephen Hawking, 2010. By embracing curiosity and seeking out new knowledge, we can continue to unravel the mysteries of black holes and unlock the secrets of our vast and enigmatic universe.